Welcome back to Unit 10 Notes. So right now let's go to page 4 of our notes. And we're going to start with arithmetic sequences. Now an arithmetic sequence has a constant addition, which means to go from the first to the second and the second to the third, you're adding a number. Now, if your sequence is going up, you're adding a positive number. If your sequence is going down, then you're adding yes, you're right, a negative number. The recursive definition is defined right here. And please remember, if you have a recursive definition, the first term has to be given. So they're going to write it two different ways. They're going to say f of n, or they're going to say a sub n. This a sub n method here is more commonly used than f of n. Again, d is called your common difference and can be either negative or positive. So let's get right into it. Let's take a look at number 1. Find the next three terms given the recursive arithmetic sequence. Well, how do I know if it's arithmetic or arithmetic? Because we're adding 8. It's got a common difference of 8. All right, so we're going to start off with our chart. Nothing new. Still doing the same old chart. Here's n. Here's f of n minus 1 plus 8. And here's my answer. Well, I know the first term is 5. So my second term will be f of 2 minus 1 plus 5. Well, f of 2 is f of 1, and f of 1 is, not plus 5, I'm sorry, plus 8. F of 1 is 5, and 5 and 8 make 13. So basically, what am I doing here? I'm adding 8. So n would be f of 3 minus 1 for the third term plus 8. So f of 2 is 13 plus 8 will now give me 21. The fourth term, so n being 4, f of 4 minus 1 plus 8, so really it's f of 3, and f of 3 is 21, plus 8 gives me 29. So the next three terms in this sequence would be 13, 21, 29. And as you can see, to go from one to the other, we are adding 8. So it all makes sense. Okay, let's go to the next page now and take a look at two methods of expressing an arithmetic sequence. You have recursive, which we just talked about, and now we also have explicit. Explicit means that you are not actually, or you do not actually need the term before to get the next term. It's explicit. It's done explicitly to one term. Take a look at these definitions. You're going to use them a lot. It's either f of 1 plus d times n minus 1, or it's a sub 1 plus d times n minus 1. All right, let's take a look at question number 3 to see if we can get a good handle on how to do this. Consider a sub n equals a sub n minus 1 plus 3, where a sub 1 is 6. Determine a sub 2, a sub 3, and a sub 4. Okay, we'll draw our chart. So instead of having an n, now we have a sub n. And then we have a sub n minus 1 plus 3. And here's my answer. It's actually arithmetic because it looks like we're going up by 3 or we're adding 3. So a sub 1, they gave it to us. They said it was 6. Okay. So a sub 2 would be a sub 2 minus 1 plus 3. Well, a sub 2 minus 1 is a sub 1 plus 3. Well, a sub 1 is 6. 6 plus 3 is 9. That wasn't too bad. Let's take a look at a sub 3. A sub 3 minus 1 plus 3. Well, a sub 3 minus 1 is a sub 2. A sub 2 is 9. 9 plus 3 is 12. One more. A sub 4. A sub 4 minus 1 plus 3, which is a sub 3, which is 12. 12 plus 3 is 15. Or we were going up by 3s. We were adding 3. So a sub 2 came out to be 9. A sub 3 came out to be 12. And a sub 4 came out to be 15. Okay, with that being said, let's answer a couple questions about this. How many times was 3 added to 6 to get a sub 4? Well, let's take a look at this. How many times did I add 3 to 6 to get a sub 4, which was 15? I added 3 once to get the 9, twice to get the 12, 3 times to get the 15. So 3 was added, 3 times to equal a sub 4. Okay, use your conclusion in B to find the value of a sub 200. If I add 3, let's see. So I had to add 3. How many times would I have to add 3 to get to 200? To get to a sub 4, I had to add it 3 times. So let's talk about this. Well then, to get to a sub 5, I would add it 4 times. Yeah, you're right. A sub 6 with 3 would be added 5 times. So to get to a sub 200, 3 would have to be added. So we're going to add 3 199 times to equal a sub 200. All right. So let's figure this out. A sub 200 is going to equal 6, because we're adding it 199 times to 6, 6 plus 3 times 199, because we're going to need to add 199 threes to the beginning guy of 6 to get a sub 200. All right, put it in the calculator, and I end up with 603. So a sub 200 is 603. All right, let's take a look at what else they're asking about this question. Write an explicit formula for the nth term of this arithmetic sequence based on the first term, a sub 1, the d, and the n. Okay, so we've talked about this, and it looked like it was being done recursively because we kept adding it to the next, to the term prior to get the next, to the term prior to get the next. But now we want more of an explicit formula. So let's say here, let's write down the actual pattern. So it's a sub n equals a sub 1 plus d times n minus 1. Now remember, where did I get this from? I got this from the top of your page, where they actually gave us formulas to use. This is the most common formula used for explicit. A sub n equals a sub 1 plus d times n minus 1. So now we're just going to fill in what we know. So a sub n equals, do we know the first term, a sub 1? Yes, we do. It's 6. Plus, do we know the common difference? What was being added to every term? You're right, 3 times n minus 1. So now we're just going to neaten it up. So we have 6 plus 3n minus 3, or a sub n equals 3n plus 3. So there's my formula. That formula will give me any term. Well, let's see if this works out. I was looking for the 200th term. So a sub 200 would be 3 times my n is 200 plus 3. Well, 3 times 200 is 600 plus 3 is 603. Does it match what we did up here when we found it by adding 3's? Yes, it does. So that explicit formula will give us any term we want in that sequence. Okay, let's take a look at the next page. The next page, we're going to skip number 4. We're going to go right down to number 5. Find the next 3 terms given of the recursive arithmetic sequence. Okay, so it's recursive, so which means we need the first to get the second to get the third, yada, yada, yada. You're kind of getting used to that. So let's draw a chart. So here's our n. It's f of n minus 1 plus 7. And here's our answer. We know the first term, which we know have no work to do, is 6. All right, so let's continue on. The second term would be f of 2 minus 1 plus 7. Well, f of 2 minus 1 is f of 1. F of 1 is 6. 6 plus 7 is, you're right, 13. Let's do the third term. F of 3 minus 1 plus 7. 3 minus 1 is 2, so f of 2 is 13 plus 7. That will give me 20. Okay, one more to do. Fourth term, f of 4 minus 1 plus 7. All right, 4 minus 1 is 3, so f of 3 is 20, plus 7 is 27. Remember, f of means the answer of that term. So f of 4 minus 1 is f of 3. So what's the answer of the third term? 20. So 20 plus 7 is 27. So the next three terms in the sequence would be 13, 20, and 27. They want us now to find a sub 100. Okay, so now they're actually writing it as a sub 100 instead of an f, and that's okay. We can actually switch forward and backwards. It's not a problem. So in order to do this, because it was recursive, in order to get the 100th term, we need the 99th term. So we need, whoops, the 99th term. Now we don't have the 99th term, but we could find it. We could actually see how many 7s we would have to keep adding to get to the 99th term. Or we can write an explicit, because in explicit you can find any term of a sequence. Okay, so we're going to write an explicit formula. I think that's so much easier. So we're going to say a sub n equals a sub 1 plus d times n minus 1. So let's fill in what we know. A sub n, the first term they gave us was 6, plus what were we adding? 7 times n minus 1. All right, so now we have 6 plus 7n minus 7. So a sub n comes out to be 7n minus 1. There's my explicit formula. Now we're going to use that explicit formula to find the 100th term. So a sub 100 is going to be 7 times 100 minus 1, which comes out to be 699. So the 100th term, or a sub 100, is 699. Now you're going to say, well, I'm kind of confused. They're going a sub and f sub. Well, basically what they're saying to you is that f of 1 is the exact same thing as saying a sub 1. They mean the same thing. So they're just writing it two different ways to show you they're interchangeable. Okay, with that being said, again today, finish all the ones that I didn't finish from pages 4 to 6. I'm pretty sure we started on page 4. I'm just double checking now. Yes, anything that I didn't finish from pages 4 to 6, you need to finish now. And then the first thing we'll do in class tomorrow is go over them.